Humanity sent a robot farther than ever before. It landed on a moon no spacecraft had ever touched. On this day, January 14th, 2005, a small probe named Huygens made history, touching down on the mysterious surface of Titan, Saturn's largest moon. This incredible achievement changed space exploration forever. Welcome to Time Shift Tech, where we explore what happened in technology on this day. Today, we read journeying over 1 billion kilometers from Earth to witness one of the most daring landings in the history of spaceflight. The story of Huygens isn't just about one day. It's a tale of international collaboration, decades of planning, and the unyielding human desire to explore the unknown. To truly appreciate the significance of January 14, 2005, we need to travel back to the late 20th century. The idea for what would become the Cassini-Huygens mission was born in the 1980s. Scientists were fascinated by Saturn and its incredible system of rings and moons, especially Titan. Why Titan? Because it was the only moon in our solar system with a thick, substantial atmosphere, even denser than Earth's. Early observations suggested it might have liquid on its surface, and its chemistry, rich in organic molecules, was thought to be similar to early Earth before life began. It was a primordial world, frozen in time, and we had to get a closer look. This led to a groundbreaking partnership between NASA, the European Space Agency, or ESA, and the Italian Space Agency. NASA would build the Cassini orbiter, a sophisticated spacecraft designed to circle Saturn for years. The ESA would build the Huygens probe, a disc-shaped lander designed to detach from Cassini and plunge into Titan's atmosphere. This was a truly global effort, with scientists and engineers from 17 different countries contributing to the mission. The cost was immense, around $3.2 billion, but the potential scientific rewards were priceless. The Cassini-Huygens duo was launched on October 15, 1997, from Cape Canaveral, Florida. Its journey to Saturn was not a straight shot. To gain enough speed to reach the outer solar system, the spacecraft performed several gravity assists, swinging by Venus twice, then Earth, and finally Jupiter. It was a cosmic game of slingshot, using the gravity of these planets to propel it toward its distant target. After a 7-year voyage across the solar system, Cassini finally arrived at Saturn on July 1, 2004, becoming the first spacecraft to enter its orbit. For the next 6 months, Cassini busied itself studying Saturn and its rings, but all eyes were on the main event, the deployment of Huygens. On Christmas Day, December 25, 2004, the command was sent. Springs gently pushed the Huygens probe away from its mothership, Cassini. For the next 3 weeks, Huygens drifted silently through space, on a ballistic trajectory towards Titan with its systems dormant to conserve power. There was no turning back. Mission Control could only watch and wait. The probe was on its own. Then came the day, January 14, 2005, the moment of truth. As Huygens approached Titan, it was traveling at a blistering speed of about 21,000 kilometers per hour. It slammed into the top of Titan's hazy orange atmosphere. The entry was a fiery ordeal. A heat shield protected the probe as friction heated its surface to over 1,500 degrees Celsius. The intense deceleration slowed the probe dramatically. Once it slowed enough, a sequence of parachutes began to deploy. First, a pilot chute pulled away the back cover, then the main parachute unfurled. The heat shield was jettisoned, exposing Huygens' scientific instruments to the alien atmosphere. For the next 2.5 hours, the probe drifted down through the thick nitrogen-rich air. This was the critical science phase of the descent. The Huygens probe was a marvel of miniaturization, packed with 6 sophisticated instruments. The gas chromatograph mass spectrometer analyzed the chemical composition of the atmosphere. The descent imager, spectroradiometer, or DISR, began taking hundreds of pictures as it descended, capturing panoramic views of the landscape below. Other instruments measured wind speeds, atmospheric pressure, temperature, and even acoustic properties, essentially listening to the sounds of Titan. What the probe saw was breathtaking. As it broke through the thick haze, it revealed a landscape that was eerily familiar, yet fundamentally alien. There were features that looked like coastlines, river channels, and deltas. But on Titan, where temperatures hover around minus 180 degrees Celsius, it isn't water that carves the landscape. It's liquid methane and ethane. Huygens was descending towards a world of hydrocarbon rivers and seas. The images showed dark drainage channels cutting through brighter highlands, leading to what appeared to be a shoreline. The view was like looking out of an airplane window over a terrestrial coast, but this was a coast on a moon nearly 1 billion miles from the sun. The tension back at the European Space Operations Center in Germany was immense. The data was being transmitted from Huygens up to the Cassini orbiter, which was flying overhead. Cassini would then relay the signals back to Earth. Due to the vast distance, the radio signals took about 67 minutes to reach our planet. Finally, after a 2-hour and 27-minute descent, Huygens touched down. The landing wasn't a hard crash. Instruments recorded a gentle thud. The probe had landed in a flat, damp plain. The surface wasn't solid rock, nor was it a deep liquid ocean. It had the consistency of wet sand or damp clay. The first images from the surface showed a landscape littered with rounded pebbles. These weren't rocks as we know them. They were pebbles of water ice, smoothed and eroded over eons, likely by flows of liquid methane. For 72 precious minutes after landing, Huygens continued to transmit data from the surface of Titan before its batteries died, and the Cassini orbiter flew out of range. It was a short-lived life on the surface, but the information it sent back was revolutionary. Huygens gave us our first and only ground truth look at this incredible moon. It confirmed that Titan is a dynamic world with weather, erosion, and a complex geological cycle based on methane, similar to Earth's water cycle. The Huygens landing was a flawless success and a testament to brilliant engineering. It marked the most distant landing ever made by a human-made object. The data collected during its descent and from the surface has been fueling scientific discovery for years. It has completely reshaped our understanding of how planetary bodies can form and evolve. We learned about the tholins, the complex organic compounds that create Titan's orange smog. We measured wines and saw evidence of methane rain. The legacy of Huygens lives on. The discoveries it made paved the way for future mission concepts, like NASA's Dragonfly mission, a rotorcraft lander set to launch for Titan in the coming years. Dragonfly will fly from location to location, building upon the foundational knowledge that Huygens provided. The landing on January 14, 2005, wasn't just a technological triumph. It was a profound moment of human exploration. It expanded our horizons and showed us a world that is simultaneously alien and familiar. It proved that with collaboration, ingenuity, and a thirst for knowledge, we can reach out and touch other worlds, even those in the cold, dark depths of the outer solar system. The Huygens probe may be silent now, frozen on the shores of a methane sea, but its message continues to resonate across the vastness of space, a symbol of our endless curiosity. This is Time Shift Tech, where we explore what happened in technology on this day. Because every date matters, and every date marks a moment in technology history. If you were fascinated by this journey to Titan, hit that like button. And be sure to subscribe and turn on notifications so you don't miss our next trip through tech history. Thanks for watching.